Hello, Wireless Craig. About a year ago, I was visiting my hometown for a funeral, and an old friend mentioned that he was paring down his collection of projects and culling the ones that he was never going to get around to working on. He had a pair of these Western Union Desk Fax machines. So last month when I was there, these jumped from his project queue into mine. So thank you, Gordon. I think this is going to be a very fun project. Now, the Western Union Desk Fax was, for all practical purposes, the very first personal fax machine. Let's get some good looks at the outside before we take the cover off. It's got an indicator and some buttons on the front. This is your incoming button, your stop button, your outgoing button, and this was an acknowledge button. If we look at this side over here, has a couple of pockets for your faxes that you have yet to transmit and one that you've already transmitted. Presuming received faxes, you're just going to give to whoever received them. Then on the back, we see it's got a little 3-conductor going to the central office and then a twist lock AC inlet for the line voltage. We take the cover off, look inside. You can see this is going to be, a little bit of an effort just to get it cleaned up and going again, recapping it and so forth. But the units do seem to be complete. And I'm looking for, some future projects and wondering which ones would have enough general interest to merit doing videos on them. And this is one that I'm considering doing a video series. So this is actually the second generation of the first personal fax machine. It's a Western Union Desk Fax, and it was introduced in 1952. If we look at it on the back, it's got the Western Union label, or the Western Union little tag, and it's a model 6500A. Look over here on this side, we can see Western Union Telegraph Company Telefax Chassis 6499A, manufactured by J.P. Seeberg Corporation. Now, J.P. Seeberg, of course, they're a story and adaptation where they went from making pianos in the 1900s to coin-operated pianos and then to coin-operated orchestrations to phonographs to jukeboxes, and at some point they got involved in making these desk fax machines for Western Union. So this isn't exactly the first personal fax machine. Western Union did a limited production that I mentioned earlier, and that was a limited trial of the earlier version before they came out with this production model. And the previous version underwent test trials for a few years, starting in about 1949, and those lessons were then applied to this version. Now, one of the biggest differences between the earlier version, which was actually quite a bit larger than this, and this version is the way that the image was scanned. In the original version, it used special conductive paper, where this version just uses normal paper and an optical pickup. Now, there's a web page. It's Brent Hilpert. He's got a web page dedicated to the Deskfax machine. It's got a lot of good information. It's got some of the signals and so forth, and I'll put a link to it in the description. The facsimile process goes like this. The customer would fill out a blank form, and these could be used to just send a telegram, of course, but they have an arrow up here, and there's a certain size specifically for the desk fax. So they would tear this out, give it to the operator who would put it onto the desk fax machine. They would line this arrow up with that arrow, and then they would roll this little garter belt over to hold it in place. Then the operator would press this little white outgoing button, and that would notify the Western Union central office that a fax was coming in. And then the office would patch, they had the manual patch cables, they would patch this subscriber line to a recording unit. Then when everything was ready, this desk fax would transmit an image of this copy to the recorder at the central office. Now, they called it a recorder, but it was really just a receiver that was printing the copy in real time onto paper. So there was no storage involved, real-time transmission, real-time receiving at the central office, and real-time printing. So now transmission was accomplished by spinning this drum at 180 RPM. And while this is spinning, the drum carriage, which is driven by a little motor down here, slowly moves to the left along this shaft at a rate of 130th of an inch per drum revolution. So that would go around once, and this would move over 130th of an inch. So as this is going underneath or as this is going across, this is the receiving head or the receiving system, has a light source over here, which is just basically an automobile headlight, has a collimating lens, and then that bounces off the paper, goes through a little aperture, and so they were targeting only detecting about an area 120th of an inch in diameter. Then the light goes through this chopper or through the collimator or the aperture, and then through a mechanical chopper and into this photosensor. That photosensor was then amplified with this little tube amplifier back here that controls the current in the subscriber line. So the central office just applied a voltage to that subscriber line, and this amplifier modulates that current. Now, when a white piece, or when a white area of the paper moves under this probe, then the light gets to this, and the way the amplifier is set up, that sends this 2400 hertz signal. And when a dark mark moves under the probe, then the line goes silent. So in this case, a mark was indicating white, 2400 hertz made by this chopper, and then when a little black line moved under this, that was the space and the line went silent. So the copy size is 4.5 by 6.5 inches, but the message area is only about 3 inches by a little less than 5 3/4 inches. So if we take that 5 3/4 by 3 inches, when the drum is spinning at 180 RPM and the drum carriage moving at 130th of an inch per revolution, that works out to be about 1 3/8 of an inch of this drum being scanned every minute. So overall, the transmission time to send a fax was 2 minutes and 20 seconds. Now, when the transmission is complete, this drum is going to be all the way over on the left-hand side, and it's going to push this little lever right here, and when that lever is pushed, then the transmit button pops back out again. Or if for some reason something goes wrong and the operator needs to abort this transmission, they can push the stop button, and it also pops that out, and it stops the transmission of that fax. So there's 3 mechanical things going on. The least critical of these is the light chopper. So if that varies, the audio signal moves from its ideal 2400 hertz to something else, but it's still going to be an audio signal in the same neighborhood. And the receiving recorder only needs to discriminate between silence and this 2400 hertz or 2000 hertz signal. And so that's a pretty easy thing to do. The second mechanism is the moving of this drum under the pickup head. If that is off, or if it varies too much, the received message would be compressed or expanded accordion style. And if there were vertical lines, they either might start to slant if the speed was just off, or they would zigzag if this was hunting. Or maybe there would be darker and lighter places where the scan lines are closer or further apart. So it's most important that this scan be consistent. It doesn't matter so much that the speed's an exact value, just that it's consistent during the transmission. And underneath, there's a synchronous clock motor that's mounted on the bottom, and they just use a rack and pinion system. So you can see right here, there's a few little gears down there on this rack, and there's a little pinion on the motor underneath. Now there's a clutch on that motor so the carriage can be moved by hand. So I'm not damaging it by moving. And in fact, what's supposed to happen is when this is powered off, there's a spring on that rack system that is supposed to pull this back by itself. So you would receive the fax, everything would shut down, and then you would hear this spinning that little gear motor, and it runs back over to the right-hand side so the operator can take the paper back off. But the most critical of these 3 movements is the drum speed. And something I didn't even mention yet is drum synchronization. This drum and the recording drum had to be perfectly synchronized, or the copy would start to scroll down or zigzag on the recorder, just like if the vertical hold on your TV were off. So say these drums started out and perfectly synchronized, but this drum was rotating slightly slower than the recorder's drum. Then if there was a horizontal line across the copy, it would get correspondingly lower and lower on the received copy until the lines at the bottom would eventually wind up wrapping around and getting printed on the top. So then when the received faxes were taken off the drum and unrolled, they would be distorted. And if one drum or the other were hunting, then the lines or the text or a horizontal line would wiggle up and down across the page. So the speed of this drum turning was very critical. So this is actually a two-step process, and they're handled differently. First, there's the initial synchronization of the two drums, this one on the transmitter and the printing drum on the recorder. And the second is sustaining that synchronization once the two drums are initially synchronized. So let's look at the maintaining synchronization first, because this was the most easily accomplished by using synchronous motors, the reluctance motors, that automatically locked into and synchronized with the AC mains. Of course, this leads to a second requirement that Western Union warns about, and that is the sending fax machine must be on the same electrical grid as the central office. So obviously, if the two units were on different grids, any variance in that grid would result in a distortion of the copy. So you could only lease and have one of these fax machines installed if you were on the same grid as your central office. Now, the initial synchronization was entirely the responsibility of the central office recorder. So when this is spinning, this sending unit has a little reed switch over here, and there's a little dimple in the shaft, and it sends timing pulses across that same current loop line to the central office whenever that reed switch falls into the divot on the shaft. And the central office the recorder has a clutch and electronics that watch that drum synchronization pulses come in, and it essentially drops that recorder into gear at the right time to match those synchronization pulses. And those are only necessary at the beginning, because once we've dropped that recorder into gear, then we're relying on the mains to keep the drums synchronized. Now on this, there's a little drag brake here. That's what this little guy right here is. It's a little drag brake on the drum, and it serves to negate any backlash in this drum mechanism by constantly applying a little load to that drum rotation. Otherwise, this drum may tend to chatter a bit, go a little faster, a little slower, and it would make the copy wiggly. And that brake was a cost-saving measure, Western Union says, to let them get away with much less precision in all of the remaining components of this very critical drivetrain. So now rotating speed was critical, but once all the backlash and the slack was taken up in the drivetrain, because this was a synchronous motor, it would rotate at a stable RPM. A couple more points, and that'll be it for sending a fax to the central office. And it'll seem more important later, but the recorder inverts the signal before printing, meaning that when we're sending a fax and it picked up white paper, it sends that, the light gets all the way through the chopper to the detector, and it sends that as the tone. So white piece of paper sends the tone. And then the recording device inverts that signal before printing. So it takes a tone, inverts it so that it's silent, and that then does not excite the print head on the other end. When this transmitting fax detected a black mark on the paper, then no light gets to the chopper or to this detector, and it sends a space, so the line goes silent. Then that's inverted by the recorder into a signal that then excites the printing head on the recorder and puts a black mark on the paper. So it all works out in the end, but it creates a little problem, more of a limitation that I'll go over into a bit. And for some reason, I guess it just made it easier that this amplifier would not invert it, they would invert it on the receiving end. And the second point about transmitting is the central office recorder drum was somewhat larger, and the lead screw only scanned at 100 lines per inch versus 130 lines per inch on this unit. So the net result was that the received copy at the central office was a little bit larger. Now, there was no additional information, obviously, but it did allow that copy to be then forwarded to another recorder in a central office, or back to another Deskfax to another customer, with the minimum loss, because it was a little bit larger. Because, a couple of things would happen. Either somebody would walk into the central office and pick up the fax, or the fax would be delivered that was actually printed by that recorder. Or the recording fax would be put over into a transmitter, and they would call up another central office and send that fax to the other central office, where it would be either picked up or delivered. Or maybe that central office would then forward it to another Deskfax machine. So there was kind of a combination. But the Deskfax was never peer-to-peer. It always went through the central office. So once a fax was received at the central office, and it was put in an envelope or hand delivered to the recipient or forwarded, like I mentioned before, but it was never just directly connected. You just did, you never just told the operator that we're going to send to another desk fax machine and send directly from this desk fax to another desk fax. It always went to a recorder, and then from the recorder either delivered or to a transmitter to another system. So we have the basics done. Let's talk about how a fax was received on this unit. So the central office would first determine that the unit was idle and somebody wasn't actually in the process of putting a piece of paper to transmit a fax on this drum. So the central office, once they determined it was idle, and to do that, they would patch the transmitter into this line, and a buzzer in this unit would indicate that somebody's going to send an incoming fax. And so somebody then needed to put a piece of paper on this receiving drum so that they could receive the fax. Now, where the transmitting paper was just paper, this is just regular paper in a book, the receiving paper was a special 3-layer conductive paper. We'll talk about that in a bit. So anyway, with the receiving paper now installed, the operator would press the Ready to Receive button, this green one. The vacuum tubes would start heating up. When they all got warm, the drum would start spinning, and these initial synchronization pulses would get sent down the line to the central office. Then the transmitter would slow its drum down until it was in lockstep with this desk fax, and then it would resume its normal operating rotating speed. And both of these were then synchronized with the grid, like I mentioned before. So now this little motor, it's just another little clock motor, puts the print head in contact with the paper. And then both the sender and this receiver begin moving their drums across the paper as the fax is transmitted. Now, I guess I don't know for a fact if the central office moved the drum or if it moved the print head. And we'll talk about the actual printer head in a minute, but for the moment, just accept that the sender unit is detecting light and dark on the paper and transmitting that as silences and tones. This receiving amplifier operates the print head directly, and so when it receives a tone, it puts a mark on the paper. And this thing is basically just a printer now. Now, when the fax is done, this is moved all the way over to the left. It bumps this little rod again, just like it did when it was transmitting, popping out the radio button. And then the operator takes the fax off. They look at it, and if it's okay, then they push this button to acknowledge to the transmitting fax at the central office that the fax was received properly. And I presume that if they didn't receive the acknowledge, then the central office would send the fax again. So back to the receiving signal. When this receiver detects that 2400 hertz tone, the amplifier in this unit, which is different than the transmitting amplifier, they decided they wanted to have 2 different amplifiers in this. But it creates a print signal, so the print head will mark the paper. And when the line is silent, then there's no mark leaving on, and it leaves the paper white. So we'll finish up with how that mark is made, but first note that these signals as a receiver are opposite of the signals as a transmitter. As a transmitter, white generated the tone and black was silent, but as a receiver, a tone generates a mark and silence means it's white. So this means that if you did attempt a peer-to-peer transfer, the receiver would be inverse, or in film terms, the negative of the sent message. Now the second problem with peer-to-peer is synchronization, since this machine has no mechanism to fall into synchronization. It only sent out these little pulses every time the drum hits that little divot, and the central office was responsible for synchronization for both receiving and transmitting. Now, Western Union was well aware of the limitations and the overall goal of peer-to-peer. Peer-to-peer faxing was always a topic of discussion if you look at any of the Western Union literature. And they did suggest a possible mechanism for getting drums to synchronize, if they were ever come out with a peer-to-peer self-synchronizing fax system. In the inversion of the copy, they never seemed to mention much, so that wasn't a showstopper, really. The fact that the fax was perfectly readable, it was just white on black instead of black on white. But the magical ability to send an image or a handwritten message allowed one to overlook such trivial imperfections as having a negative image. Now, in all the Western Union articles I've read where they mention the ultimate goal of peer-to-peer faxing, one thing they never mention is how Western Union was going to monetize those peer-to-peer faxes. Of course, back in the day, you didn't own this fax machine. You just leased it from Western Union, just like you leased your telephone from AT&T. You didn't own a telephone back then. But once the faxes were no longer going to the central office, it wasn't clear to me how Western Union was going to get their pound of flesh. Now, for large corporations with their own switchboard, Western Union would lease you a 30-line fax concentrator that would serve as the central office for both recorders and retransmission. So I should mention that the reason a number of these desk faxes survived until today is that when they were taken out of service at Western Union, the amateur radio operators latched onto them because they could pick up one of these things for $20 and with a modification or two begin over-the-air faxing over their radio. Now, there's a number of articles on the modifications, including a few on how to get the transmitter and the receiver drums to synchronize. This is a 1975 book that Gordon also had, and there's a lot of good information on this, on how it works, synchronization, what you need to do, schematics on how you need to modify it, making a positive picture out of it instead of a negative. Then they go on how to receive weather satellite images, but this is all specific for this actual machine, which was one of the only ones at the time. So if we look at the bottom of this thing, I don't know if it has been modified for radio, but on both of these that Gordon had, the bottom plate was completely missing. So you can see there should be a plate here. That's completely missing. Haven't dug into it yet to see if it's been modified for radio, but you can see it's just a bunch of point-to-point wiring, some capacitors that'll need to be replaced and so forth. But like I said, overall, it looks to be in very, very good condition. This little synchronous motor, by the way, is the motor that moves the drum across. That's the one that has a pinion on it that moves the rack across. So nice and clean. Somebody hasn't been in there chewing it up. So Gordon did a good job of keeping these things in good condition. One more little interesting bit, at least I thought it was interesting, and that is that back here in the top, this is an inking wheel. And so there's a little part under this that's actually the inking wheel, this little disc, and then this is the ink reservoir, this little red part. The purpose of this, Western Union, the prototype version of these didn't have it, and that was one thing they learned, is that people tended to send the same fax over and over again because they didn't leave a mark on it that fax was actually sent. So in this little rack and pinion, there's a little notch right here. Let's see if I can get that up where you can see it. Not really. There's a little notch on the rack that as this moves across in that one little spot, it allows this to come forward and touch the paper. And so, this is really going fast, but in real life, it would leave, a narrow line across that entire paper. But for the life of me, I couldn't figure out how this thing worked until I realized that somebody had disabled it. All of this mechanism that's on the left-hand side, this whole arm needs to be flipped over so that it's over here. So that leads me also to believe that maybe this went to a radio operator. He didn't need to have that line, so he just took it off and reversed it, so it was basically inoperable. Thankfully, he just didn't take it off and throw it away. It's still there. All I got to do is flip it over and put it back to work. But the purpose of that is you look at a fax and it would have a line about an inch from the left-hand side, and if it had that line, it meant that fax had already been sent. So I think I covered everything about this machine except how the actual print head made the marks on the paper. Now, I mentioned Brent Hilpert at the beginning. Well, Brent also started me on one end of this, radio operator's chain of connections, and ultimately led me to another radio operator named Harold, who has some of this special paper. And Harold has been gracious. He's offered me this paper from his private reserve. So Harold's going to send me some of this special printing paper. It's called Teledeltos paper, and it's a Western Union invention in the mid-30s, specifically for faxing. So it's conductive paper that is coated with an opaque gray surface on one side and aluminized on the other side. So it's got 3 layers: thin aluminum on one face, conductive paper, and this electrosensitive gray coating on the other face. Now, when a current is passed through this paper from face to face, this electrosensitive gray coating will turn black. So the paper is the exact same size as the transmitting faxes, except it's this special conductive paper. It's put onto the drum with the aluminized side touching the drum and the gray sensitive side on the outside. Then hidden back here, can't really see it, but there's this little arm, and right in there is a little tiny tungsten wire. That little wire, it has about a 10 mil tip on it. And this motor right here, when it's time to print, this motor brings that tip in contact with the paper. So now that tip is in physical contact with that conductive paper. Now when this receives the tone, the amplifier runs a current through that little tungsten tip, runs current through the paper, and that gray surface, that electrosensitive layer, turns black. It takes about 10 or 20 milliamps through that tip, which, considering it's only a 10 mil tip, that's a lot of current density through that little tip. Now, Western Union says the paper is electrosensitive and turns black through a chemical process. On Brent's Deskfax webpage, he says it's more akin to just burning off the coating. And, it made a bit of smoke, but I suppose fire can also be considered an electrosensitive activated chemical process. Of course, I don't have this guy working, and I don't have the paper, so I can't weigh in at this point what that's actually like. But, if we do a video series on this, then we'll eventually see that. Now, I guess I haven't actually mentioned what the project is. To get this up and going is really only the first part, to get it cleaned up, to get everything moving properly, recap it, so forth. And since I have two of these, I can have them talk to each other. Western Union made a peer-to-peer interface table, they called it, and Brent has the schematic for that and Western Union description of that table on the website. But it's basically a passive circuit that just cross-connects the signals. There's no synchronization in this and no inversion. So if you did peer-to-peer with that system, you'd wind up with a fax that, was just randomly started on the page. The bottom of the page would have the top of the fax, and the top of the page would have the bottom of the fax. And also there might be a line going across diagonally because these drums aren't synchronized. But at any rate, you could transmit. And the other thing is that if you had a positive image on this one, you would receive a negative image on the other one. Now, Western Union actually had a little test image or a test fax to send when you were using this table that was white on black. So you could use the white on black on this one, basically the negative, to make sure that the receiving one would then come as a positive. But what I want to do is to create a central office. So it's probably going to be with either this little STD bus system or maybe STK85 or the SBC85 or this MCS 85 system, something. I want to make a central office. So this central office wannabe will function as a recorder to invert and receive the copy and then digitize, store, and send it up to the computer over the serial port. So as a transmitter, it'll take a fax, download it from the computer, and then send it to this Deskfax. It's going to be an exercise in level shifters and interface signals. There's 3 wires in this interface. The transmit data is current loop, and the interface signals are DC, going between the plus and minus 100-volt rails and a common. So there's the opportunity for things to go wrong, but nothing's overly complicated, and I think it's adequately documented. So that's the end project that'll follow the first project of getting this thing cleaned up and running. So this one unit, the other unit has some mechanisms that are a bit frozen. This one seems to be in better condition. Both of them are very clean underneath, but I haven't really dug into either of them yet to see if they've been modified or if things are missing. But they appear to be complete, and so restoring them shouldn't be the biggest part of the project. So that's it for this video. As I said, let me know if this is a project that's of enough interest to bother making a little video series on, getting this up and making a little central office. As always, this channel isn't monetized, and the only figure of merits are subscribers, shares, and clicking that like button. And frankly, that's how I decide what projects to do. So if you want to see a project like this, shares and clicking the like button are certainly appreciated and an indication. Okay, thanks for watching. I will talk with you later. Bye-bye.